Okay, obviously, greenhouse gas emissions are very critical for tracking carbon cycle and global warming and the feedbacks that we looked at in the last chapter. So let's start with this figure from EPA, which shows carbon dioxide dominating the total greenhouse gases that the world emits. These numbers change a little bit, but basically the story is the same. Almost 65% is from fossil fuel and industrial processes. There are flue gases from electrical activities, refrigeration, cooling systems, etc. Nitrous oxide from agriculture, fertilizer and other things. Methane from agriculture, cattle, wetlands, etc. Carbon dioxide from forestry and other land use is about 11% here. That is just to orient you. But when we look at where all these carbon goes, we looked at where all the heat goes from the additional energy that we are trapping. So this is a nice figure from UCAR, which has a course it puts on Comet, which cover various topics as well. So where does the carbon dioxide go? Atmosphere stores about 40% of whatever total we are emitting. 30% is in the land cover and 30% is in the water. So 93% of the heat goes into the ocean, but about 30% of the carbon dioxide goes into the ocean. Okay, so this is not good news because ocean acidification is a serious concern, as we will see later on in this chapter. So what is happening? Global fossil fuel CO2 emissions just from 1990 onwards, there are some ups and downs. We have been looking at the Keeling curve. When you take out the annual cycle and just look at the lower frequency trends, this is what you get. So the increase was about 1% per year during the 1990s. It jumped to 3% per year during the 2000s, and it has now flattened again during the 2010s. And COVID brought the entire system to its knees, so there was a significant dip, about 5.4%, and the 2021 numbers are not in yet, but the projections say we are going to be going right back to where we were, and a lot of the incentives that were created for economic recovery post the COVID crash have all gone into not such great green activities. This is the tragedy of our short attention span. Economic development, economic recovery, wealth obviously take precedence when there is a push come to shove, and climate action will always take a backseat unless green technology becomes so pervasive that everything we do will be green. So we are expected to jump back by this year, which is already obvious. There are little dips you get because of the financial crisis in 2008, but you can see that we again get bailouts and so on, and we jump right back to where we were before these little dips. So Soviet Union dissolution created a little dip here, and so on and so forth. Let me add a little bit of details about this, a little bit out of place, but it doesn't matter. One of the main things that is happening in the natural carbon cycle and in the perturbed carbon cycle is, of course, vegetation and photosynthesis and respiration. So everybody has seen this in some elementary school or high school, where plants basically capture solar energy. They all have solar cells, which allows them to take carbon dioxide, mix it with water, which they pull up from the roots, or they live in the water like the algae, and they use sunlight to produce C6H12O6 with the chlorophyll or plastids they have, and then they release oxygen. Of course, when they respire, they burn the sugar they built to do other things, growth, reproduction, somatic and gonadic maintenance, and so on and so forth, and they release CO2 and H2O and energy as well. So of course, if every molecule of sugar or carbohydrate or hydrocarbon that gets put away into the soil or into the bottom of the ocean or lake or whatever, without getting respired, releases an additional molecule of O2 and takes away a molecule of CO2. Right, so that's the critical sequestration by the biological processes. Leaves have stomatas where they open, so roots are pulling up nutrients and water, and they are very valuable commodities. And the stomatas have to open to capture CO2 when the light is available. So they open, and stomatal conductance is designed in a way that they don't want to lose water and oxygen too much while capturing CO2, which means what happens when CO2 increases, as it is happening now because of human activities. It turns out that evidence suggests that the stomatas have become more efficient in the water use, so they don't have to open as long because CO2 is higher. So they close earlier, so they are rejecting some of the water they have pulled up based on evolutionary instincts in the place that they are living. So there are interesting consequences of increasing CO2 as well. So coming back to the emissions then, looking at a longer time scale and looking at multiple sources, this is the balance of sources and sinks again in gigaton carbon. Be careful. So this is going from about the Industrial Revolution to almost recent times, last couple of years. So total estimated sources do not match total estimated sinks, which we will see in a minute. So what are the sources? Of course, fossil fuel carbon, including the carbonation sink. So fossil fuel is very commercial and valuable commodity, so it's tracked pretty closely, and we know pretty much how much carbon gets emitted, and you can see the little depths related to the dissolution of Soviet Union or financial crisis or COVID and so on as well. Land use change is releasing some CO2, so those are the main sources, but there is also cement, steel, aluminum and other things which are not included in this particular balance. Ocean is taking up, so we are burning more and more fossil fuel. We have kind of equilibrated on the release from land use. Ocean continues to take up more and more, and so does land, because as atmospheric CO2 increases, there is CO2 fertilization of the vegetation, and soils take up some more based on the difference in partial pressure of CO2 in the air and in the soil or in the ocean. The question is, how long can this continue? When will they saturate and stop taking up more carbon dioxide? And of course, the remaining amount is accumulating in the atmosphere, which is what we said in terms of 4 ppm per year increase in atmospheric CO2. These calculations, measurements averaging over the globe, leave some residuals. So those are known as the missing sink or residuals or imbalances. So you can see there are times where the imbalances are higher and there are times when they are lower. These variabilities, as in the Charles-Keeling curve, are related to El Nino and La Nina, where ocean can take up more, release more, droughts and floods where carbon can be released, wildfires and other things, and so on and so forth. Okay, so atmosphere obviously is easier to measure than the ocean, which is vast and deep, and we don't have as much carbon measurement, or we cannot measure it as easily as we can in the atmosphere. So here we are again looking at annual fossil fuel CO2 emissions for different countries with projected number that we saw before. So this is the total for the globe from 1960 onwards with 2021 projections. China, which was quite low, has had economic booms since about 1990, which makes it now the biggest emitter. USA has reduced its footprint along with Europe, not necessarily because they are getting poorer, but they have shifted their fossil fuels from more polluting ones to better ones, like natural gas, for example. And there are other changes in vehicular efficiencies, exporting manufacture. So when you look at these numbers, you have to be careful because China is emitting a lot, but it's manufacturing many things which are being imported by other countries, and there is the embedded carbon. So China is emitting for us. If we don't manufacture and buy from China, China is emitting, but we are responsible for some of that emission as well. So we have to be very careful about that as well here. So India is also beginning to grow. It still remains quite low, but it is going to pass the European Union as its emissions continue to rise. So you can see the numbers here. Out of the total of 14.8 gigaton CO2 in 2021, China had 11, USA 5, EU 2.8, and India 2.7. Okay, these are just fossil CO2 emissions. You can also look at it as per capita, which gives you a slightly different impression because USA still dominates in terms of per capita, even though that is also dropping. So USA is at about 14.2 tons per person just from fossil fuel CO2 emissions. Russia is at 10.8. Japan, China is getting close to Japan and will pass probably at some point. These are per capita, so you have to still multiply it by the population to get these numbers, of course. EU is up there, and India remains low, but in these, again, the tricky thing is that the top 5 to 10% rich people in China and India consume at these levels. The poor people consume much less, so when you average, you're getting low numbers. So we have to be careful that consumption doesn't continue to increase as economic development happens, because as people get richer, their per capita emission tends to go up and up and up, from using cars, buildings, their food consumption, their travel and luxury items, and so on and so forth. But these have to come down, and these should be allowed to go up some more as well. So those are part of the negotiations under IPCC. So this is the same thing now. Why am I showing this again? This is separated into coal, oil, gas, and cement. So that's the point. You can see that cement is increasing, so the construction boom in India and China continues to increase. Cement is one of the most polluting materials we produce by using natural resources. Gas, coal, which is still distressingly high. COP26 has decided on phasing out coal, but the numbers are not very encouraging because some coal plants will continue to operate even in very progressive countries like Germany, and last coal plant even in a country like Norway will not close for another 10-20 years. And while US is not burning a lot of coal, it's exporting coal. Australia is exporting coal. So there are all kinds of things we have to worry about. Okay, so oil is growing, everything continues to grow, of course. Just to add another point, here we are looking at where the maximum per capita emissions and populations are. So we are looking here at carbon and populations. So US is a small population but emits a lot. Russia is next. China has a large population but is not emitting as much. European Union is a smaller population, not emitting that much. Indonesia, Brazil, India, large population, not emitting much, and so on and so forth. So world average is 1.3 tons per capita, but US is up here. These numbers, again, they are not always the same because the units keep changing, so one has to be very careful about where we are in carbon and where we are in CO2 and so on. So this says fossil CO2 emissions, but it is showing carbon and not CO2. Okay, so let me leave this here to give you a sense of the emissions and so on. Keep those numbers in mind, and there is incredible amount of data excellent graphics available in our world in data in terms of the different sectors from where the emissions come from. Energy is almost 75%, but out of that, transportation, buildings, industries, agriculture take up a lot of the energy. Agriculture independently emits buildings and various other activities like cement production, aluminum, steel, and so on and so forth. Okay, just educate yourself as much as possible on carbon sources and sinks.